Hey friends, welcome to the YouTube channel all about electronics. So in this question, we have been given this frequency synthesizer circuit which consists of this phase lock loop and the divide by end counter. So here, this divide by end counter has 4 outputs, that is divide by 2, divide by 4, divide by 8 and divide by 16. Moreover, here the input signal frequency is 5 kHz and we have been given that the free running frequency of this PLL is set to 20 kHz. That means whenever the input signal is not present at that time, the output of this PLL will be equal to 20 kHz. So here, through the switch, the output of the divide by end counter is given to the PLL. And here we have been also given the order in which this switch is getting connected to these outputs. So based on the connection of this switch to this divide by end counter, here we have been asked to find the output of this synthesizer. So when we use this PLL along with this divide by end counter, then it can be used as a frequency synthesizer. So as shown in the diagram, one of the input to this phase detector of the PLL will be equal to the reference signal and the one input is the feedback signal which is coming from the divide by end counter. Let's say it is equal to FF. So this phase lock loop circuit changes the VCO frequency such that this feedback signal FF is very close to Fi. So in this condition, if we see this output signal frequency of the VCO, then this Fout is equal to this Fi times N. Because as you can see, here this output signal is getting divided by the factor of N. Therefore, when this feedback signal is same as the reference signal at that time, this output signal frequency is N times the input signal frequency. So in this case, this divided by N counter has 4 outputs. And using the switch at any given point, only one output is connected to the phase detector. So these outputs are divided by 16, divided by 8, divided by 4 and divided by 2. And here we have been also given the sequence in which these outputs are connected to the phase detector. So first, whenever this divided by 16 is connected to this phase detector, then the output signal frequency F0 is equal to 16 times Fi. And in this case, this input signal frequency is equal to 5 kHz. That means when the switch is connected to the divided by 16 output, at that time, this output signal frequency of this frequency synthesizer is equal to 80 kHz. Similarly, at the second time, when the divided by 8 output is connected to the phase detector, then the output signal frequency F02 is equal to 8 times Fi. That is equal to 8 times 5 kHz. That is equal to 40 kHz. Then at the third time, when the switch is connected to the divided by 4 output, then this output signal frequency F03 is equal to 4 times Fi. That is equal to 4 times 5. That is equal to 20 kHz. And at the fourth time, when the switch is connected to the divided by 2 output, then this output signal frequency F04 is equal to 2 times Fi. That is equal to 2 times 5 kHz. That is equal to 10 kHz. That means if we see the order in which we get the output across this frequency synthesizer, then it is equal to 80 kHz followed by 40 kHz followed by 20 kHz followed by 10 kHz. So in this order, we will get the output at the frequency synthesizer. And therefore, for the given question, this D is the correct answer.